You can see, just waiting for my train. 6:36 up to Edinburgh. I'm only going as far as Bristol though. And this is one of the pictures I took from my flight. You can see just in the middle to the left there's a grey dot, which is the Stade de France, where the French play their football and rugby. And this is the highest mountain in Europe, Mont Blanc, which you can see above the cloud line. This is as we're just coming into Geneva. Right, well I've just arrived at Cern. This is the main entrance here, and you can see what I assume are some of the tubes or tunnels that the accelerators are in. And then if you can look just over at the back there, mountains. Didn't even notice them when I first arrived, but they look like clouds. Now we'll go and find the hotel that I'm staying in and drop my bags off. Just there. Okay, I've just arrived at Cern. I've checked into my hostel stroke hotel room, and this is it. I think I haven't had a look round yet, but let's go. So there's my bed, and there's my wife ringing. Right, back again. Yeah, just arrived today. I did a little clip earlier on, but was kind of interrupted. I was on a bit of a short time span. Anyway, this is my room. We'll have that tour that I promised. Okay. Now here are the wardrobes, and this is the view from my room. It looks very much like any industrial site, although I don't know if you can see here, all the roads are named after famous scientists. I'll see if I can catch one later in the week. There's my desk, there's my bed, and bathroom. Reminds me very much of my halls of residence. Anyway, in about an hour or so, I've got to meet up with the other people that are on this week with me. We're going to get an introduction to what's going to happen during the week, which should be really quite exciting. Anyway, I'll leave you with that for now. Morning, it's the Tuesday morning. It's what, 7:30 coming up to. Just got up. I'm just about to go and get showered and everything. Got a really interesting day ahead. I'm having a cosmology lecture this morning, which is going to be quite interesting, looking at stars and what happens there. And then this afternoon we are making a cloud chamber, which is something I'm hoping that we can do in school. I've heard of them. They look for evidence of cosmic radiation. So hopefully I'll be learning how to build one of those and make one of those, and hopefully you'll see one in a moment in assembly. I hope. Right, bye. Hi. Right. Oh, I'm a bit hot, warm. I've just been out for a walk. Anyway, let me tell you about today. It's been a fantastic day today. There was an introduction about what Cern is and what they try to do and how they do it, which was very interesting, and I was able to get answers to a couple of questions. Charlie asked how much is the upkeep of Cern and who pays for it? The budget that Cern run on is 1 billion Swiss francs per year, which is about 700 million pounds, 810 million euros, or 1.08 billion US dollars. Sounds a lot of money, but it's the same as a medium-sized university in the UK. So university like Exeter, I think would probably be a similar size. And as to who pays for it, there are, I think, 20 member states which all contribute to the running of it, to the council. They have each of them has two members, one political, one scientific, and they get one vote as to into the running of Cern. So it's run by the 20 member state governments. There was another question that was asked. Are scientists religious, or the scientists that work at Cern religious? I wouldn't say that I haven't seen any churches or synagogues or mosques here on the site, as it is purely a research lab. But there are many different languages that are spoken by the people here, and I think this is one of the only places where there has been a joint party in which was specifically for 5 Israelis and 1 Palestinian who was working on the site here. So the second part of the day was a bit more hands-on. I had a tour of where they make the magnets, which I will show you in my edit. I'll try and put that in here. Okay. This is the warehouse where they test the magnets. You can see in the background there the tunnel. That's a mock-up of the tunnel with the accelerator running through it in the blue tube. Here's a close-up. You can see the 2 pipes in the middle here. That's where the 2 beams of protons are fired. The side view of the tunnel, you can see there the copper, which is the superconductor, and then you've got the where the beam flies through there. That's being cut off. Now this is a scale model of them lowering the magnets in. You can see the blue tubes, which are the magnets that contain the beams, and you can see how big they are in relation to an Arctic lorry there. You can see the cranes that they have that hold them and lower them down into the tunnel there. So this is just a model showing how they do it. Also learned how to make a cloud chamber, which puts Einstein's theory of relativity. It's an experiment to prove this, and that's really quite interesting to do, and I'm hoping that we'll be able to repeat that experiment in school. We need to get over some dry ice, which I'll have a word with Mr. Inley and Mr. Brown and see if we can get some in, so we can have a go at that. But yeah, I shall put how to make that in here. A basic setup of a cloud chamber involves a wooden crate that you can see under the bottom that has a metal sheet laid on top of it. Now underneath that metal sheet, you can't see it, but there is silver foil and there is dry ice, which is solid carbon dioxide. Now on top top of the black metal sheet there is a plastic fish tank. It's very important that it's plastic, because glass can have adverse effects on the rays that we're trying to look at. Now you might be able to see just at the top there's some felt, and that felt has had been drenched in propan-2-ol, and then all around the metal there's propan-2-ol as well. Now you can't see too much here, but the dry ice is causing the propan-2-ol to evaporate, and we should be able to see in the next clip some cosmic rays. We've got the light tower here, and you can see the propanol that's evaporating. It kind of looks like a rainy effect. Now you'll see in a moment a big line going across just there. There we go. Now that was caused by the cosmic rays, which are essentially muons, which are very, very big electrons. They have a negative charge and they cause the propanol to ionize. Now when it ionizes, it falls out of the evaporation and turns back into a liquid, and that falls and causes that trail. And you should be able to see quite a few little ones, but not very many big ones. Now this is really interesting. Now the protons that they fire come from hydrogen atoms, which come from hydrogen molecules. Now this red canister is where all the hydrogen molecules are stored before they go into the accelerator. This is one of the first proton accelerators to be used. It was built in the late 60s, and it was the first one that was able to curve the protons and curve the beam. You can see the orange parts of the magnets and the coils, and then you've got the detector there, which is the silver part. Got some free time now, so I'm going to go and get some dinner. Yeah. Anyway, see you later.
Of everything we've seen into it since then. So we have, rather than just the up quark and the down quark, we have this set of three generations of quarks. Up and down, Cern, strange top and bottom, with their matching electron and neutrino. And this lightest set is what builds everyday matter. But we have these duplicate extra sets which are heavier and behave basically very, very like the light generation. But because they're heavier, they can split up into lighter components, whereas the lighter pieces, by being light, can't split up into heavier components. So you don't tend to see these ones around in nature for very long. You probably are aware that muons are one of the most frequently encountered of this set. Standing here, you got about 1 muon a second going through you. These are rather penetrating and made in the upper atmosphere, and they live briefly, but you can see them all the time. That's what you would see in a cloud chamber if you, or a horoscope for cosmic rays. You'd watch muons raining down. So this is what we understand that matter is built of. And then we have the forces that interact with matter. The four forces, the strong nuclear force.
In one of the buildings they have a high resolution picture, a life-size picture of the CMS, and you can see how big it is. You can just about make out the guy working in his office there. That's him, and then that's how big the actual detector is. This lecture was about the accelerators and how the accelerators actually work. Now they don't actually increase the speed. The speed of the particles travels at just below the speed of light, about 99.999% of the speed of light. So they generally refer to that as 1 to make their calculations a bit easier. Now what they do is they use something we use in school, Fleming's left-hand rule, which tells you that the magnetic field and the electrical field are able to cause movement, and that's how they get the particles to move at the high speeds that they need, and they try to increase the energy of the particle rather than they accelerate the speed. Now this also shows the cosmopolitan policy that they have there. The doctor speaking here is Italian, and he's doing here is physics speaking in English, as that's the general language that any of the physics is discussed is always in English. Yet the day-to-day conversations are normally done in French. So when you go to the restaurant, that's all in French. This is a live webcam that's broadcasting from the International Space Station, the ISS. They have the control room for the particle detector that they have on top, which you may just be able to see on the right hand side near one of the blue mirrors. Now they're out there detecting the cosmic rays and looking at how they behave. The data is stored on one laptop on the ISS and then transferred to Florida and then back to Cern. Now this is Mick, who's our educational tour guide. Now he is showing the detector that's on the ISS. Now this has to be quite sturdy because it has to be knocked around, which when you compare that to the detectors at Cern, they have to be very, very carefully looked after. This is the main control room for the LHC, the Large Hadron Collider. There are 4 different sections. This first section, which I'm pretty sure that guy in the middle table is playing World of Warcraft, but I couldn't be too sure. That first section, they look after the accelerators at the LINAC. The second one, they look after the top left, which is out of our picture now. They look at the PS, the proton synchrotron, and then this one here where they have all the champagne bottles, which I understand is where whenever they have something to celebrate, they put their champagne up there. Now that last one there, sorry, is where they do monitor the LHC, the main collider, and then in the top right hand corner is where they look after the cryogenics, the temperature, and monitor and make sure that is all running at the correct temperature. Which, if you can remember back to 2008, there was a breach in the welding between 2 of the magnets, and that caused the temperatures to go from the 1.9 Kelvin only up by 4 degrees, which caused the super cold helium to evaporate, causing a massive dent and explosion, which put the project back about a year. Okay, let's just adjust this a little bit. End of day 3. I'm off out for a meal with the people from Cern and the rest of the people on the course in a little while in Geneva. I've managed to pick up some books about the construction of the compact muon solenoid experiment at the LHC. The lives of Galileo, the guy that invented the telescopes. The lives of Marie Curie, who discovered radioactivity. And the lives of Einstein, who came up with the theory of relativity. And then this is a pop-up book of the heart of the Atlas experiment here at Cern, which is one of the detectors here, which hopefully you'll be able to find and read in the library. Had 2 lectures in the morning. The first one about particle physics, looking at how they look for evidence of the Higgs boson. At the moment they can't say for sure that it is the Higgs, but it is a Higgs-like particle, which they've got evidence for and supported. They're doing a close down the accelerators for about 2 years. Saturday just gone, I think 16th of February, and that's for 2 years while they do some maintenance on the accelerators to try and increase the speed. And this was one of the questions that was asked. How fast are the protons travelling, or the particles travelling? They are running at around about 99.9% of the speed of light, which is what they call, which is 300 millimeters per second, which the particle physicists working on accelerators refer to as 1. That way they can use Einstein's theory of relativity, E equals mc squared, to say that energy and mass are the same thing. So they use a term called electron volts, and they're looking for the Higgs, which has a mass and an energy value of 126 giga electron volts, which is quite a lot of energy. So that was the first lecture. The second lecture was about how the accelerators work and how they use precision mathematics to set up the electromagnets so that they will accelerate and move or increase the energy of, I should say, the particles in the accelerators, and they have to do that by collaborating with the physicists and the engineers, so that the engineers can set up the electromagnets to the correct, to give the correct magnetic and electric fields, so that they can move in the right direction. That obviously takes some complex working, and obviously a bit of engineering skill is required as well. They did offer summer jobs for anybody that wants to do any welding to weld the magnets together. Personally, I don't think I want to be given that sort of responsibility. But yeah, so we did that, and then this afternoon we went to the AMS, which is a detector that they're using to detect cosmic rays, which is on the International Space Station. They had the control room for that there, which gets its data via Florida and the Kennedy Space Center, and it streams the data straight to Cern, where it's processed there. They don't collect quite as much data there as they do with the Hadron Collider, the Large Hadron Collider here at Cern. We then went to the Cern Central Control Room, the CCC, and that's where they monitor the accelerators. So they look at how the performance of the accelerators is working, and they also look at the conditions that the accelerators are kept in, and make sure that they're all present and correct, and working in particular working order. Now, as I said earlier, the accelerators are not on, but there was still a pretty busy control room looking at the maintenance, and obviously they're heating up the tunnel as it's at 1.9 Kelvin, which is minus 271.1 degrees C. So they're heating that up to room temperature, or to normal temperature, so that people can go down there and do the necessary repairs. Anyway, that's the end of day 3. Last day tomorrow. Looking forward to it. Day 4 today. It's 8 o'clock. I'm just about to go and have some breakfast. This morning's quite interesting. We're looking at the CMS. We're going to understand how that works, and then later on this afternoon we're going to go and have a look at the CMS to actually see it, not in action because of there's no beam at the moment, it's all closed down, but I'm really looking forward to my favourite part of the week. It's the medical applications of particle physics, and looking at what impact they will have on medicine, and you know, a lot of talk is spent about, you know, why spend, you know, £1 billion Swiss francs on this place when, you know, there are better things to spend the money on. And I think you know, these breakthroughs in medical science are the key thing for this. So I'm looking forward to seeing what they bring. We had a a brief chat about it the other day, and how they're looking at using proton beams rather than gamma rays to try and treat cancer. So I'm looking forward to learning a bit more about that, and that would probably answer one of the questions I think from Jim. What applications in the future will there be? Obviously in the past there's been all sorts, such as the internet, which is the main thing that's come out of Cern. So looking forward to looking at what's coming up in the future. Anyway, speak to you later. Now, this guy is an American physicist who works on the CMS, and I'm not going to try to pronounce his name, but he doesn't work for Cern, but works for the University of California. Now, there are 20 member states for Cern, of which America is only an observer state, so they can't actually have employees, but do contribute money in the fact that this guy is working at Cern. This was the talk I was most looking forward to. It was from Manjit, and she was the exotic particle, as she describes herself, where she's the only life science specialist at Cern. She takes the applications and the equipment that they use at Cern and tries to find a medical use for them. One of the problems they have is that they don't have the budgets to spend on advertising, so doctors are a little bit apprehensive about using this technology, whereas the drugs companies put a lot of money into their research. It can be a shame, really, as there is a lot lower risk with this use, as they can target cancers especially, and use hadron therapy to help reduce the cancer. Now, this is a picture of me outside a life-size picture of the CMS, just outside the hole where they lowered it down, just before we went down into the tunnel. And this is where you can see me actually getting ready to get on the lift down into the tunnel, with my hard hat as a safety precaution and my ID badge, so everyone knew I was okay. This is the other group getting into the lift, and I thought I'd put this on because you can see how quite tightly packed it is as they close the doors. And no, they can't close them. They've got to wait for somebody else to get in. And anyone that was on the Poland trip will remember what the trams were like when you think there's no more room, and then somebody gets in, and there is a bit more room. Wow. End of day 4 today. It's been a really interesting day. Spent the first part of the morning looking at a very interesting lecture by an American scientist. I can't remember his name, I can't pronounce his name. All about how the cosmic muon solenoid, which is the second detector that they use to confirm or have confirmed data from about the Higgs boson. It's absolutely fascinating, and it's the first lecture that I've understood about 90% of it. So that was really interesting. We then had the second lecture, which is the lecture I've been looking forward to all week, about medical applications. Now, earlier in the week I said that they were looking at how they can use protons, and they use hadrons, which are a type of proton, in the treatment of cancer. And you'll probably read a bit more about this with the write-up that I do. But very interesting about how they currently use X-rays and radiotherapy to treat cancer, when actually using particle accelerators and hadrons would get rid of cancer without doing the extra damage that it does to the living tissue. So it can focus purely on the cancerous tissue and not on the living proper tissue that we need. So that was really interesting. But there's a very big problem that they have here at Cern is they have the technology here, but they're not using it in medicine, and that's one of the things that they have a problem with, that doctors are not aware of what information or what facilities they have available here that can treat illnesses such as cancer. Going back a few hundred years ago, when 1895, when the first X-rays were introduced, a fortnight later they were being used in medicine. I was able to go and have a look around Geneva, and this is some of the pictures I took. This is from the top of the cathedral, looking over Geneva, and this is the copper carbonate tower. There you go. There's a bit of science for you. Copper carbonate tower, and then this is the dodgy taxi we took across the river taxi. Sorry, not the river, across the lake. And this is the present here that Mrs. Wood was quite glad she received. Solid diamond watch. Yeah, I don't think my wages could afford that. Good morning. This is my last entry for while I'm in Cern. It's been an absolutely mind-blowing week. It's been completely fantastic. Every single thing that I've done, I've enjoyed. I've learnt so much, and I think there's so much I can take back to school, and I look forward to coming back again, hopefully with a group of students. Anyway, I hope you've enjoyed the video, and put some comments about this video underneath. Thank you. Bye.